Welcome back. Okay, what I want to look at is GCSE mathematics, okay? And the subject area we're going to look at is matrices, okay? Matrices, okay? Now what I want to be sure of is that get it fully on in view. Yes, okay, that's good. Okay. Now the work here you need to be able to do for yourself, and you need to write this out for yourselves as well, so that you can understand the concept. Now these were lessons I delivered, as you can see, back in 1991, but the mathematics element is still relevant to this day and will always be relevant even into the future, okay? Because you must be able to understand matrices. Doesn't matter what area of work you're going to, it is relevant. Now a matrix is a rectangular display or array of numbers arranged in rows horizontal and columns vertical, which is used to present information. It is enclosed by a large pair of brackets. The plural of matrix is matrices. Arrays of numbers have been used to present information, or could have been used to present information in previous units, okay? We're just looking back at the fact that we may have used units before, but this won't apply to you because you have not done my units previously, okay? So you will take it from this point in time. In Unit 9, never mind Unit 9 because you have not done Unit 9. You have not done Unit 9. It's okay, something seems to come across my mind. Okay, right, so that will not be relevant to you, okay? But in that we just refer to simple interest, compound interest, etc., etc., etc. Okay. Now here we have rows, and these are our columns. Okay, 1, 2, 3, 4 columns and 5 rows. Okay. If this table were being used by those who understood its purpose, the row and column headings could be omitted and the number array presented as a matrix with 5 rows and 3 columns. Okay. Five rows, 1, 2, 3, 4, 5 rows. Columns, 1, 2, 3 columns. Okay. Now, what is the purpose of that? The purpose here is, one, you need to be writing this information out for yourself so that you understand your learning style and you adapt and apply your learning style and method. Okay, I am only presenting this to you from my perspective and my learning style. You need to develop that learning style for yourself, and that is important that you understand that. And you do that by extracting the information, drawing out the diagrams as they stand, putting in the information. Then you can use that to reflect and change the data to then see how it was implemented and achieved. And you can do that by practice, practice, practice. Okay? Now the matrix is said to be of order 5 by 3. Five by 3. 5 rows, 3 columns. Okay? I repeat, 5 rows, 3 columns. 5 by 3. The curved brackets around a matrix hold it together and show that it is complete. In reading the matrix, the number on the fourth row in the second column is 1.262, and this is the amount which £1 would increase to if it had been accumulating interest at 6% for 4 years. Now, never mind unit 11, okay? That's just some work that I would have done previously, but this does not apply to yourself, so don't worry about this bit here. Leave that, okay? Let's just deal what is relevant to you, okay? Here we have men, hours, days. So what are we going to say here? 12 men did 8 hours over 5 days. Okay, so if the table is complete and the column headings omitted, the information becomes a matrix with 2 rows and 3 columns. Here we have 2 rows and 3 columns. Column 1, column 2, column 3. And here's our data, okay? This is our data here, okay? So here we have 10 men doing 6 hours over 8 days, 12 men doing 8 hours over 5 days, okay? Now, this matrix is a 1 order 2 by 3. Two by 3. So what? 2 rows, 3 columns. Okay. Well, again here we'll ignore this because this is not relevant to you, but it's just telling you what we have done previously, okay? But which you have not done yourselves, but it's going to act purely as information only, okay? Okay. Now, all we are looking at now is going to use this table from unit 14 to give an illustration, but don't you worry about unit 14, okay? It's not relevant to you. It's only this example that we are utilizing that is relevant to yourselves, okay? So here we have color, boys, girls, total. So how many columns do we have? We have 1, 2, 3, 4 columns. How many rows? 1, 2, 3, 4, 5 rows, okay? So this message is going to be what? A 5 by So, okay, it's a 5 by 3. I was trying to see if I could avoid that, telling you let you see if you can get that to you for yourselves. But okay, if the row and column headings are omitted, the array of data is presented as a matrix of order 5 by 3. Okay, I was trying to get out of it. Okay, which means we have 5 rows, 1, 2, 3, 4, 5 rows and 3 columns. Okay. And again here we're just showing you a simple process of, now again write these out for yourself, get familiar with the matrix system, matrices, etc. Okay. Alright, now so you should be able to apply this for yourself now, and all I'm doing now is showing you how we have 5 by 3, 5 rows, 3 columns. Okay. Okay. Right, now in these matrices, the two numbers in the first row and the first column, 3 and 0, both represent a number of boys wearing red shirts. If they are added equals 3, the total is the number of boys wearing red shirts in the two classes. Okay. Similarly, the two numbers in the fifth row and the third column, 2 and 14, both represent a number of students wearing white shirts. If they are added, that comes to 16. The total is the number of students wearing white shirts in the two classes. These totals can be written in a third matrix, giving information about the two classes combined. Okay? And this is where we would have our third matrix. Okay, let me just shift a little bit. Matrices can be added, okay, if they are of the same order. A 5 by 3 matrix can only be added to a 5 by 3 matrix. It cannot be added to a 4 by 3 matrix, and if it makes sense to add them, again here we're just talking about another unit, so not relevant to you. To add matrices, corresponding numbers or elements in each matrix are added. Okay. And here we have our examples. Okay. And here's what we've done. Three plus naught, 12 plus naught. Let me show you how this is done. Okay, in this case, as to what they've done here. Goodness me. Okay, let me just get my drawing pen out. Okay, and we want a bright color, don't we? Yeah. Yeah, I can go with that. Okay. So if we're adding this, what we're going to be doing here, we're going to add this to this, okay? That becomes that, then becomes that here, okay? Okay, so that there equals that. This here now will be added to, and I'm going to try and wiggle it through, okay, will be added to this here, okay. So that becomes 12 plus 0, so that, this here now becomes, represents this one here now, okay. I know it's a bit messy, but I'm just trying to show you how it's done. And this here now, I could try doing it with different colors, but I was looking at the timing of it, okay, becomes that here plus this here, okay, and these two here simply now becomes is represented by this, okay, and that's how we, and then the same thing is done applied again, okay, and then what you then have here, this then becomes 3 plus 0 it equals 3. You then get, when you add these results here, you get this result here, okay, you get the whole of this becomes that, okay, so, and that's what we then get, okay. Now you need to write these out for yourself so you understand the concept and you bring in your own learning style and method of learning. This is important for you as an individual. And subtraction of matrices. Again, follow the rule. We can only subtract matrices. Once again, matrices can only be subtracted if they are of the same order and if it makes sense to subtract them, okay. And here we are. Here's our example. Let me just change my color of my thing. Give me a purple, okay, okay. Here we are, okay. This is what we're subtracting. Okay. Sorry, let me rephrase that. This is what we're subtracting. So we're taking this from this, okay? And again, we're looking at it from this little piece here, okay? It then comes deal with this bit here first, okay? So we subtract 3 from 6. That would then leave us 3. And then we then take 4 minus 0, leave us 4, okay. And you can then see how these pieces here become relevant to us in each case, and that's what you need to be doing. Now, by writing this out and doing the subtraction for yourself enables you to understand the principles behind the matrix subtraction. It's important that you do that for yourselves, okay? Okay, now again, I think I'm talking enough, and I'm assuming now that you've got fair ideas as to how this can be done for yourself. Okay, let me just look at this one here, okay? Multiplication of matrices by normal numbers. It may also be sensible to multiply a matrix by a normal number, example 3 children by sweets each week as shown by the following matrix, okay? To calculate the quantity of sweets bought during a year, we multiply each number in the matrix by 52. Okay, so here you can see that we are now, have I got my pen still? Here you can see we've got the 52 here, okay? Times in by the data we have collected. Peter bought 3. Peter then bought 2. Joanne bought 1 and 5 and 0. Okay, so that data then comes into here. We've now also shown here that this, when we do that, this is the result we then get. And we know that result is correct because when we times this number by that, it gives us 156. So when we times 3 by 52, it gives us 156, and that's what you need to be doing for the rest of it. I'm not going to do it all for you, because this is now important that you begin to write this out for yourself and apply your method and style of learning so your brain understands the concept behind it. Okay? I think I'm talking enough now, so I'm just going to take on down, okay, slowly. Again, this is relevant for you to be doing for yourselves, okay? Did I? Okay. Again, multiplication matrices similarly to what we just done at the top, okay? I'm using the highlighter because I want this to be understood by yourselves, and for those of you who may have peculiarities in viewing of certain colors, I've used yellow, and I hope that's not a problem for anyone, basically, because yellow is normally quite a neutral color in itself, okay? If it is, please let me know by simply making a comment, okay? So, okay, I'm just going to go back up to this and shortly in a moment, okay? So just bear with me for a second, okay? I'm just trying to highlight it so that it's easy to read, okay? Bear with me for a minute while I go back up, okay? Okay, right, okay. Now again, write these out for yourselves. Make sure you understand the concept behind it. Apply for yourselves overall, okay? Nothing more for me to say here, basically, other than the principles behind it, and it shows you the answers that you should have here as well, so you should be able to work this out for yourselves, okay? And you can see here that we have multiplication can take place, okay? Okay, so it's showing you here how to multiply. And remember utilization of this. See how this has been done, okay? 5 times 1 plus 2 plus 2 times 7. Okay. Right. Look at this carefully and do a little bit more groundwork on this area to make sure that you understand the concept and that I haven't made an error myself, okay? So check, 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 please. And all I've done here is giving you some notes, okay, and multiply out the following matrices, and here are your examples exercise. Please do the exercises, okay? It enables you to find a lot of information and it improves your knowledge, okay? And here I've given you the answers to some of those exercises, but do the exercises first before you begin to look at the answers. Okay, thank you for your time. I hope you have found this quite useful. Have a good day. Bye bye.